So hello guys, this is the um my summary for the chapter 7, which is all about the IP addressing. So addressing is a critical network layer protocols. Why? Because it's all about the IPv6 and the IPv4. Addressing is enables data communication because through this address each host and the computer or each computer can communicate to each other. Addressing enables data communication between hosts regardless of whether the hosts are on the same network or on different networks. The both Internet Protocol version 4 and Internet Protocol version 6 or the IPv4 and IPv6 provide hierarchical addressing for packet that carry data. Designing, implementing, and managing an effective IP addressing plans ensure that networks can um, operate effectively and efficiently. Um, the IPv4 addresses is all about it is 32 bits, I guess. So, what first of all, what we call the binary. What is binary? So, binary is a numbering system that consists of the numbers of zeros and ones, or called bits. In contrast, the decimal numbering system consists of 10 digits, consisting of the numbers 0 to 9. Binary is important to understand because the hosts or servers and network devices are binary addressing. Specifically, they use binary IPv4 addresses. Yes. So IPv4 addresses is using the binary system. Each addresses consists of the string of 32 bits divided into four sections called octets. So the four section what that is what we call the octets. Each octet contains 8 bits or 1 byte. It is separated with dots. Remember that. Separated by dots. And later on, I will discuss what is the difference between those IPv4 and IPv6 separation. So, for example, PC1 in is assigned IPv4 address of 11.1.1.0.0.0.0.0 dot 1.0.1.0.1.0.0 dot 0.0.0.1.0.1.0.0.0.0.1.0. So that is example of IP of an address that this consists of binary numbers. Work with binary numbers can be challenging. For ease of the use of the people, IPv4 addresses are common, expressed in dotted decimal notation, and is assigned to IPv4 addresses. Like 192.168.10.10 and its default gateway addresses is 192.168.10.1. So the positional notation. Learning to convert the binary to decimal requires an understanding on positional notation. Positional notation means that a digit represents different values depending the position. As from its word itself, positional notation. Then the digits occupies in the sequence of the number. So positional notation refers to the position of the digit in that occupies in the sequence of the number. So the decimal position notation system operates decimal. So in contrast, the binary positional notation operates binary. So binary to decimal conversion. So how we convert binary to decimal? So to convert an IPv4 addresses to its dot decimal equivalent, divide the IPv4 address into 4 8 bits or octets. Next, apply the binary positional value to the first octet binary number and calculate accordingly. So That's how convert the IPv4 to the binary. Decimal to binary conversation. It is only necessary to understand how to convert dotted decimal IPv4 to binary, a useful tool in binary positional value table. So, decimal to binary conversion. Then, network and host portion. Understanding binary notation is important when determining if two hosts are in the same network. Recall that that an IPv4 addresses is hierarchical addresses that is made up of network portion and host portion. When determining the network portion versus the host portion, it is necessary to look at the 32-bit stream. Within the 32-bit stream, a portion of bits identify the network and a portion of bits identify the host. The bits within a network portion of the addresses must be identical for all devices that reside in the same network. So, excuse me. So the bits within the network must be what we call identical. Because how can you deliver a message if you have same addresses? It is like sending a message to you. Then the subnet mask IPv4 addresses or has a unique IPv4 address of the host. Subnet mask used to identify network host portion of the IPv4 address. The default gateway identifies the local gateway to reach remote network. When IPv4 address is assigned to a device, the subnet mask is used determining the network address where devices belong. The network addresses represent all the devices on the same network. Then the logical AND. A logical AND is one of the three basic binary operations used in digit logic. The other two are OR and NOT. So when it's AND, so there are the binary operation used in digit logic, the and the other are the OR and NOT. While all three are used in data networks, only N is used determining the network address. Logical N is a comparison of two bits that produce the result, which is the binary version of the address. To identify the network address of an IPv4 host, the IPv4 address is logically ended bit by bit with the subnet mask. So ended by bit with the subnet mask. Then the prefix length, expressing network addresses and host addresses with a dotted decimal subnet mask addresses can become cumbersome. Fortunately, there is an alternate shorthand method to identify the subnet mask called the prefix length. Specifically, the prefix length is the number of bits set to 1 in the subnet mask. It is written as in slash motion, which is a slash sign, followed by the number of bits to set to 1. Therefore, count the number of bits to the subnet mask and prepend it with a slash. So, the static IPv4 addressing assignment to the host. Device can be assigned an IP addresses either statically or dynamically. In network, some devices required a fixed IP address. Um, For instance, printer, servers, and network devices, and an IP addresses that does not change. For this reason, these devices are typically assigned static IP addresses. A host can also configure with a static IPv4 addresses such as um, that that PC or devices. A Assigning host static IP addresses is acceptable in small network. However, it will be time consuming in order or to enter static addresses on each host in a large network. It is important to maintain an accurate list of static IP addresses assigning to each devices. Then, after we go to the static, let's go to the dynamic IPv4 for address assignment to the host. In most data networks, the larger population of hosts include PCs, tablets, smartphones, printers, and IP phones. Um, it is often case that the upper population of their devices changes frequently. It would be impractical to statically assign IPv4 address to each devices. Therefore, these devices are assigned IPv4 addressing dynamically using the Dynamic Host Configuration Protocol or DHCP. So, IPv4 can be assigned also by the dynamically using the Dynamic Host Configuration Protocol or DHCP. DHCP is generally the preferred method of assigning IP address to the host on large network. In additional benefit of DHCP is that address is not permanently assigned to the host but is only leased to the period of time. IPv4 communication. The IPv4 communication are in three ways: the unicast, broadcast, and multicast. When you say it unicast, is only from individual to another individual, only one person. But when you say it broadcast, it is from one computer to all, sending to all. It's broadcast. The multicast is the process of sending a packet from one host to a selected group. So in multicast, it is only for the only selected group. Unlike broadcast, it is for all. Multicast is only for a group, a specific group. The unicast transmission or unicast communication is used for normal host-to-host communication in both a client, server, and peer-to-peer network. Unicast packets use the address of the destination devices as the destination address and can be routed through an internetwork. The broadcast transmission or broadcast traffic is used to send packets to all hosts in the network using the broadcast addresses for the network. With the broadcast, the packet contains the destination IPv4 addresses with all ones in the host portion. Now, this means that all hosts on the local network broadcast domain will receive and look at the packet. Many network protocols such as DHCP or DHCP use broadcast. When a host receives a packet sent to the network broadcast addresses, the host processes the packet as it would a packet addresses to its unicast address. Broadcast may be directed or limited. A directed broadcast is sent to all hosts on a specific network. For example, a host on the 172.16.40/24 network send a packet to the 172.16.4.255. A limited broadcast is sent to the 255.255.255.255 by the default. Router do not forward broadcast. The multicast the transmission. Multicast transmission reduces traffic by allowing a host to send a single packet to the selected set of hosts that subscribe the multicast group. As I said before, multicast is for group. Special use of IPv4 addresses. It can be loopback addresses in the linked local addresses and the testnet addresses. The legacy classful addressing. So, the RFC divided the unicast ranges into specific classes called the Class A, Class B, and the Class C. Class A is 0.0.0.0/8 to 127.0.0.0.0/8. And the Class B is 128.0.0.0/16 to 191.255.0.0/16. And the Class C is 192.0.0/24 to 223.255.255.0/24. So next, when we're finished for the IPv4, now we're going to the IPv6. IPv6 designed to be successor to the IPv4. IPv6 has the largest 128 address spaces, providing for the 340 undecillion addresses. So IPv4 has only limited addressing, but through the IPv6, which has 128-bit addresses, it can provide 340 undecillion addresses. That is enough for all of the devices that we have in the whole world. Need for IPv6. The rebellion of the IPv4 addresses spaces had been the motivating factor for moving to IPv6 as Africa, Asia, and other areas were to become more connected to the internet. There are not enough IPv4 addresses to accommodate this growth. IPv4 has a theoretical maximum of 4.3 billion addresses. That is too small. Private addresses is the combination of the network addresses translation or not has been instrumental in slowing the depletion of the IPv4 addresses space. However, NAT breaks the many application and has limitations that several impeded peer-to-peer communication. IPv4 and IPv6 coexistence. There is not a single date to move to the IPv6. For the foreseeable future, both IPv4 and IPv6 will coexist. The transition is expected to take years. The IETF has created various protocols and tools to help network administration migrate their network to IPv6. The migration techniques can be divided into three categories: dual stack, tunneling, and translation. Dual stack Dual stacks allows IPv4 and IPv6 to coexist. Tunneling is the method of transporting IPv6 packet over an IPv4 network, and the translation network addressing translation or NAT allows IPv6 enabled devices to communicate with the IPv4 enabled devices using a translation similar to NAT for IPv4. Then there are also an IPv4 addresses type. It is the unicast, multicast, and anycast. Unicast, an IPv6 unicast addresses uniquely identifies an interface on IPv6 enabled devices. And the multicast, an IPv6 multicast addresses is used to send a single IPv6 packet to the multiple destination. Anycast, an IPv6 anycast addresses is any IPv6 unicast addresses that can be assigned to the multiple devices. IPv6 prefix lengths. Recall the prefix or network portion of IPv4 can be identified by the dotted decimal subnet mask or prefix length or slash notation. IPv6 uses a prefix length to represent the prefix portion of the address. IPv6 not use the dotted decimal subnet mask notation. The prefix less is used to indicate portion of IPv6 addresses using IPv6 address prefix length. So the prefix length can be ranged to 0 to 128. A typical IPv6 prefix length for LANs and other types of network is 64. This means that the prefix or network portion of the address in is 64 bits in length, leaving another 64 bits for the interface ID or hosting portion of the address. In IPv4, the separator that is used is dot, but in IPv6, the separator that is used is also dot, but it's different, double dot. Then, this is my summary for the chapter 7 and about the IPv4 and IPv6.